Hi, Algebra 1 students. Today we're going to be taking a look at factoring trinomials by grouping. This method is a method that we also use when we have larger, more complicated polynomials. So this will help us in the future with factoring as well. For now, we're going to stick just to trinomials. And down in the description below, I've put a link to Mr. N's video. We're going to be using the same exact problems as examples in this video so that you can see that both methods are valid and in fact work. So then you can make a choice on how you want to go about factoring your trinomials. So let's take a look at our example number 1 here. 2y squared plus 15y plus 7. So our first step we're going to do is multiply a times c, so that would be 2 times 7, we get 14. Then we're going to list all of the factors of 14, and we're going to be taking a look at what are all the factors that add to 15. So let's start. We got 1 times 14, 2 times 7. And you know what? We have found it already. We have 1 and 14. Those, in fact, add to 15, right? So those are the two factors we're going to be using. And instead of making this X or diamond method bottoms up like you saw in Mr. N's video, what we're going to do with these two factors is we're going to split this 15y. So let me rewrite our problem. We're going to keep the 2y squared, and we're going to keep the plus 7 over here. But instead, we're going to take this 15y and we're going to split it up into two different terms. We're going to split it into plus 1y and plus 14y. Notice that if we were to combine like terms, we'd end up back here at our original problem. And now the actual factoring by grouping part. When we say by grouping, we're going to take a look at these first two terms and then take a look at these second two terms, and we're going to factor those separately. So let's take a look at these first two terms. 2y squared plus y. They have a greatest common factor of y. So I'm going to factor that out and get y times 2y plus 1. And there's our first group factored. Now I'm going to take a look at our second group. And I've noticed they have a greatest common factor of 7. So I'm going to factor that out as well. 7 times y plus 2y, 2y plus 1. And I'm going to make sure I have this plus in the middle. These are going to stay here. So, notice something interesting happened. We have factored both of these separately, but they have a common factor themselves. So now if we take a look at our resultant polynomial, we have two factors, or two terms, 1 and 2, and they both have a common factor of 2y plus 1. So we're going to factor one more time. We're going to factor out what they have in common. 2y plus 1. And when we factor that out, what we're left with is y plus 7. And this is going to be our final factored form. So let's now take a look at a second example. And then we'll go over the exact steps we're taking. So first we're going to multiply 3 times negative 8. That's our a times c. And we get negative 24. Then we're going to look for the factors of negative 24 that combine or add to equal positive 10. So let's take a look at our factors. We have 1 and 24, and one of them needs to be negative, right? To be a negative 24, doesn't matter which, but those aren't going to add to 10 anyway. We have 2 and 12, and one of them needs to be negative. In fact, if the 2 is negative, these now add to positive 10, and we could stop finding our factors at that point. So now, again, just like before, we're going to split this 10x into two parts using those factors. So let's rewrite our problem. 3x squared, my minus 8's still there, and now the splitting. It'll be minus 2x plus 12x. Now we've split that, and we can go into the factoring by grouping. Our first group, it has a common factor of x. When I factor that out, I'm left with 3x minus 2. In my second group, they have a common factor of 4. And when I factor that out, I'm left with 3x minus 2. Notice again that I have the same common factor. So we're going to factor one more time. We're going to factor that out. 3x minus 2. That's these guys. We factored it out, and we're left with these two. X plus 4. And that is going to be our final factored form. Lastly, let's take a look at the steps we just did in those two examples. Let's lay them out. So to factor trinomials by grouping, the first thing we did, step 1, was to find the value of a times c. Step 2, we found the factors of that add up to b, that middle term. We then rewrote that middle term, bx, as the sum of our first factor, x, and our second factor, x. In these steps, I wrote f1 and f2, respectively. In step 4, we grouped the two pairs of terms on the left and the right. Then we factored a GCF from each group. We noticed that then they had themselves a greatest common factor. So in step 6, we factor out that GCF from both terms. So now let's take a look at just a couple more examples doing those 6 steps. Again, a is 1 in this case, times c. It's negative 6, so a times c, we're going to get ourselves negative 6. We're going to look for all the factors that add up to negative 1. So we have 1 and 6. One of them is negative. Those aren't going to add to negative 1. If we have 2 and 3, and the 3 is negative, now we get negative 1. So let's do our split. We'll rewrite our problem with our middle term, bx, split into 2x and negative 3x. Now we're going to do our grouping. We see there's a common factor of x. We factor those. We get x times x plus 2. Our second group here has a common factor of negative 3. So notice now we have a negative right here. Usually the same as this symbol here. So we factor out that negative 3 and we're left with x plus 2. Again, notice these are the same. So we're going to factor that out as well. So let's factor the x plus 2 out, and we're left with the x minus 3. And we have successfully factored another problem. 2 more examples here. Let's do it again. A times c is 24. We're going to list all our factors that add to 10. So 1 and 24, those don't add to 10. 2 and 12, they don't add to 10. 3 and 8, they don't add to 10. 4 and 6, hey, they add to 10. So that's how we're going to split this up. We rewrite our problem. With that split, 10x is now split into 4x plus 6x, right? We group. On the left-hand side, we have a common factor of 2x times x plus 2. We group again. On the right, we have a common factor of positive 6. We factor that out, and we get x plus 2. Again, the same number. So we'll factor that out as well. And then we're left with 2x plus 6 as our second factor. And we've factored another. Last example here. Let's take a look. A is 1. So a times c will be negative 3, so that's that 1 times negative 3. And we list its factors. We could have 1 and 3, and either one could be negative, so really our factors are these. And they're one pair of them is supposed to add to negative 7. It doesn't look like any pair adds to negative 7. So what that means for this method is that this is prime. There is no way for us to factor this. This polynomial is prime, meaning we can't factor it. So with that, I hope you check out Mr. Nakauchi's YouTube video. Again, it's linked in the description below. He goes over the same examples with a different method, and we hope that by knowing these different methods, you can make an informed decision about which you prefer. And if you get stuck in one method, maybe try the other method so you can find an error or mistake, or maybe you find out, hey, you had the right answer the whole time. So with that, I'll see you next time.